sum. In the second sum, we have been given a parallelogram PQRS. If PQR is a parallelogram, then the opposite sides are parallel and equal. So SP is equal to RQ. Similarly, RS is equal to QP. So this conclusion we can make. L is a midpoint of side SR. L is a midpoint of side SR. SN Sn is drawn parallel to LQ, which meets RQ produced at N. Okay, so RQ we are just producing further and it is meeting at point N. And cut side PQ at M. So we have to prove that SP is half of Rn and Sn is equal to LQ. Now let's consider a triangle RSN. So this triangle we consider. In this case, SR is a side of a triangle and L is the midpoint of SR, and they have given that SN is parallel to LQ. Okay, and this LQ is a line segment which is passing through the midpoint of one of the sides of a triangle and is also parallel to SN. Now this is the given which is in a converse of midpoint theorem. So, so what is the conclusion of converse of midpoint theorem? If there, if L is the midpoint of one of the sides of a triangle, and the line segment passing through this midpoint, which is parallel to the third side of a triangle, then the LQ, the line segment, bisects the third side of a triangle. That means Q also midpoint of Rn. So on these things, on the given point, we can conclude, like see what we have written here in triangle SRN. Okay, in triangle SRN, LQ is parallel to SN. Okay, and L is the midpoint of SR. Therefore, we can write RQ is equal to QN. And what is the explanation you can give? Converse of midpoint theorem. Okay, so this is equation 1. Now we know that quadrilateral PQRS is a parallelogram. Okay, so in PQRS, RQ is equal to SP. What you will write? Quadrilateral PQRS is a parallelogram. You have to write explanation for each and every point. Fine. Now here we can see that from equation 1 and 2, we have to cover that SP is equal to half Rn. Okay. So from equation 1 and 2, we can write SP is equal to Qn. Okay. So Qn is nothing but what? Half of Rn. So we can here prove that SP is equal to half Rn. So this way we can prove the first point. Now we will go to the second one. What second one they have given? That we have to prove that Sn, that means this one. Okay, Sn is twice of LQ. Now from first equation we have proven that Q is a midpoint of Rn, which we have proven, and L is a midpoint of SR, which is given to us. So in triangle SRN, L is the midpoint of side SR. So what you will write explanation given. Q is the midpoint of side Rn, which you have proven above. Okay, you can write this way. Therefore, we can write LQ is half of Sn. So this is what your midpoint theorem. So you can write the explanation over here. This is as per the midpoint theorem. Therefore, Sn is equal to LQ. So this way you can prove. So you can see here we have used either converse of midpoint theorem or midpoint theorem as per the information given. Now we will go to the third one. Okay, in this case, the adjoining figure shows a parallelogram ABCD. So now this is a parallelogram. So definitely DC is parallel to AB. Okay, which is given to us. P is a midpoint of AB. Now P is a midpoint of AB. So we can write AP is equal to PB. And Q is a midpoint of CD. So DQ is equal to QC. But ABCD is a parallelogram. So here we can write AB is equal to DC. What explanation you can give? That quadrilateral ABCD is a parallelogram. Okay. So here DQ is equal to QC and AP is equal to PB. This is given. So from 1 and 2, we can conclude. Now these two sides are equal. Okay, so definitely DQ is equal to PB. Okay, so DQ is equal to PB. So we can conclude that DQ is equal to PB. Okay, now here we know that DC is parallel to AB. So definitely if DQ is equal to PB, then DQ and PB are the part of the segment DC and AB. So we can conclude that DQ is also parallel to PB. Hence, we have proven if one of the opposite sides of a quadrilateral are parallel to each other and are equal to each other, so we can say that given quadrilateral PBQD is also a parallelogram. Okay, it is also a parallelogram. So if it is a parallelogram, then we can see that other two sides are also parallel to each other. So therefore, QB is parallel to DP. Hence, okay. Now here we can consider a triangle DCE. This triangle we can consider here. Okay. So we can write in triangle DCE. Okay, QF is a part of DB, DE is a part of EB, EP, and we have already given here that Q is a midpoint of CD. Okay, so we can write Q is the midpoint of CD. Next is QF is parallel to DE as PBQD is a parallelogram. Okay, so this is the given in a theorem, converse of midpoint theorem. This is the given data. So on the basis of this given, we can conclude that F is a midpoint. Okay, so here we can conclude that FC is equal to FE. On what basis we can prove that converse of midpoint theorem. Okay, now similarly we can go for this triangle, this one. Okay, so in triangle ABF, okay, already given that P is a midpoint of AB, so we can write P is a midpoint of AB, and also we can write PE is parallel to BF. Okay, because we have proven that PBQD is a parallelogram. Okay, so again this is what converse of midpoint theorem given, or information which is given in the first statement of converse of midpoint theorem. So we can say that AP is equal to PB. So this is again as per the converse of midpoint theorem. So this is equation 1, equation 1, and this is equation 2, or equation A and equation B also you can say. So similarly, just a minute, Here we need to make some corrections. AE, na, this is given. Na? So here we have to go for AE is equal to EF. AE, because this is given us. So this we have to prove. This is equal. So AE is equal to EF. So from equation 1 and 2, we get that AE is equal to EF is equal to FC. So this way we can prove. So here we have used either midpoint theorem or converse of midpoint